Welcome to Surveying Lectures by Civil Thinking, and this is our another module, and this module is Theory of Errors in Observations in Surveying. So before I move on with this module, I suggest you to please watch the video lectures on surveying one by one as in the playlist so that you understand better. The playlist link is in the description, or also you can click on the pop-up on your screen. Now coming to the today's class. Now this is our new module and this is our first lecture in this module. So we will see different types of errors and what we can do to minimize those errors in this module. Okay, so we know the theory of errors. Okay, this is a famous theory and we will see it in the surveying. Okay, so let us read and we'll see. Surveyors use measurements to map land and build structures. So you know the surveyors, what they do, they measure the different measurements in the field. Okay, and with the help of those measurements we can we can estimate and we can use those measurements in different aspects of building structures, right? But no matter how skilled they are or how good the tools, every measurement has some error. Okay, so you should keep in mind we always have error. Okay, so when we measure something, okay, it does not matter what device you use, okay, or how experienced the surveyor is. Okay, so when we measure something there is always error. Okay, always error, and we cannot fix this. We can reduce this error, but we cannot fix this 100%. Okay, there is no way we can fix it 100%. Okay, so we can only reduce the error. Okay, reduce the error or keep it in the permissible limits. Okay, but we can never remove this error. Okay, so irrespective of the device you use, okay, whether you use expensive devices like total station or whether you have a surveyor with more than 30 years of experience, it does not matter. There will be errors, it will always be there. Okay, so let us move on. Now understanding these errors helps surveyors pick the right tools and methods so mistakes stay small enough to not harm the work. Okay, so we have to keep the errors within the permissible limit. Okay, so we have to keep the errors in the permissible limit because we cannot remove the errors. So the only we can do is we can keep them in permissible limits, or we can reduce them as much as we can, okay, to be more accurate. So that is why we need to know about this, the theory of error. Okay, the theory of error, and we need to know different kinds of errors. It is very important. So when we know what could be different reasons for the errors, what could be the different sources of the errors, so we would be kind of able to keep them under limit. So now when we measure things, okay, when we measure something, we can measure it directly. Okay, so we call it as direct observation. Or when we cannot measure something directly, we have to measure it indirectly from other measurements. Okay, so let me give you an example here. So we have two kinds of measurements. Okay, two kinds of measurements. So one is direct measurement, and the second is indirect measurement. Okay, so what we can do indirectly, for example, you have 2 pointers on the ground. Okay, if you want to measure what is the distance between them, so you might use a chain or a total station or a tape. Okay, and you will be able to know. Okay, directly you will place the the end, you will begin the chain from here or the tape. Okay, and you will spread it to this point, and you will know what is the measurement between the 2 points. Okay, what is the distance between the 2 points, so that is known as direct measurements. Okay, So when you can directly measure, okay, but maybe sometimes we will not be able to throw this chain between these 2 points, okay, or throw the tape between these 2 points. Why? Because there might be some obstruction. For example, let us say we have an obstruction here, so we cannot throw this chain from this point to this point, okay. So we will not be able to directly measure from this point to this point, okay. So what we do, we will measure this distance indirectly, okay. So maybe we will measure this distance, okay, then we will measure some angles, okay, and all of that. So when we measure indirectly, so that is called as indirect measurement, okay. So let me give you an example in the indirect measurement, okay. For example, you have a river, okay, this is a river, okay, this is a river, and you want to measure, for example, you are here, okay, and you have measured up to this point, okay, up to this point. Now you need to measure this, okay, you need to measure this from, let us say this is point A and this is point B. So you need to measure the distance from A to B, but because we have a river here, so we cannot throw the chain from A to B, okay. So for example, let us say this point was C. From C to A you can measure with the help of chain or a tape very easily, okay. But what do we do here? So we will apply some indirect measurements, okay. So from in this, A to B is like it is the width of the river, right? So this is the A to B, this is, let us say W, it is the width of the river. So you want to measure it, okay. So what you will do, okay, because we are going to do again and again, when we come to these indirect measurements, okay. But right now I will give you a quick overview, okay. So let us say you want to measure this AB distance, okay. So what you will do, you will measure some, offset, perpendicular offset from A, okay. So this is perpendicular, okay, this is the offset distance, okay. Let us say this is point D, okay. Then you will measure another, okay, but it has to be on the, line of sight, okay, like this. So you will measure another offset from here, okay, from C you measure another offset, but you will keep them such that this B, D, and let us say this is point E, they are all, they are all on the same straight line, and that process we call it as ranging, okay. So we will keep them, so we will keep, on the other side of the river. For example, let us say we have some stuff here, because we have surveyors, the surveyor is not only one, we have a team of surveyors. Some people will, some surveyors, they will come from this side, okay. So they will maybe, they will position a ranging rod here, okay, and you will put a ranging rod on this point too, okay, and then you will put a ranging rod on this point too, and then you will observe, and they will be on the same line, okay. That is known as ranging, okay. So when you know they are in the same line, okay, so then you will also draw this perpendicular here, okay. Now from the, trigonometry, from the mathematics, from the trigonometry, let us say this is theta1 angle and this is theta2 angle, okay. Now you will know, because this is a straight line, right? BDE is a straight line, it means theta1 and theta2 is going to be same, okay. So theta1 is going to be equal to theta2, okay. It means the tangent of theta1 is also going to be equal to tangent of theta2, right? Because theta1, they are equal, right? So now what is the value of tangent of theta1 from this triangle? Now tangent of an angle is perpendicular divided by base, okay. So from here, tan theta1, the perpendicular is AB and the base is AD, okay. So AB divided by AD, right, it is equal to what? It is equal, now tangent of theta2, this is the perpendicular, okay, let us call this as point F, okay. So DF divided by FE is the base, okay. So DF divided by FE, okay. Now if you multiply both sides with AD, okay, multiply both sides by AD, so this AD and this AD will cancel out, okay. So let me just remove them. So you will get this AB, right? AB is the width, okay, and you was not able to measure it directly, but now you will be able to measure this AB. Why? Because DF, this DF is here, DF, you can measure it here, right, using chain or a tape, right? So you know the DF. Now FE is this. Again, you can very easily measure this with the help of a chain or a tape, because there is no obstruction. So you can measure this. Similarly, you can measure AD, this AD, right, using a chain or a tape or some other instrument. So you will be able to measure this. Okay, now you will multiply and divide, okay, these things, and you will get AB. So basically you got this AB, which was not possible to measure directly. You measure it indirectly. Okay, so you applied trigonometry. Okay, so you applied trigonometry, and with the help of trigonometry you was able to measure it. Okay, now let me tell you one more thing about error propagation. Okay, error propagation. Okay, so what is error propagation? It is basically when you apply mathematics to wrong measurements. For example, I have told you there is always some error. Okay, so DF, there will be some error always. FE, there is also some error, okay, small error, and AD, there will be also some small error. Okay, so when you multiply and divide all of these errors, they got also multiplied and divided. Okay, and this AB, it also got some error. Okay, so you got this error indirectly by mathematical operation. Okay, so this is known as error propagation. Okay, so let us move on. So I have told you about a direct observation, okay, or an indirect observation. Okay, so I have denoted it with direct measurement or indirect measurement. That is same as direct observation or indirect observation. Okay, I just used the different words, but they are one and the same thing. Okay, so I have also given you this example of the river, okay, using trigonometry. Okay, and I also told you about this error propagation. Okay, whenever you compute a value from other measurements, the small errors in each measurements combine. This mixing of errors is called error propagation. Okay, so I have already told you about this, so let us move on. Okay, now errors in measurements. Now how do you compute the error? Error is the difference between An error is the difference between what you observe and the true value, which you never know for sure. Okay, so we write it as E equaled, okay, x minus x bar. Okay, x minus x bar. Okay, so x is what you measure and x bar is the true value. Okay, so if you want to measure the distance between 2 points, okay, so you are using a tape, for example. Okay, so you use a tape, so it is observed value or measured value. Okay, observed value. Okay, but there is some true value of this, true distance between them. Okay, but we never know, we never know the true value. Why do we don't know the true value? Because no matter what instrument you use, there will always be some error. So how can we know the true value between the distance between them? So the true value is always unknown. Okay, it is always unknown. Okay, so you should keep this in mind. Okay, the true value is always unknown. Okay, so we measure error. E is equal to, let us say, x is this observed value minus x bar, and this x bar is the true value. Okay, true value, and we never know this. Okay, so this E, it is the error. Okay, so error is obviously the difference between what we observe and what is the true value, right? That it is obvious, that is the error. Okay, so from here what you measure, the observed value, that is x. Okay, so that is x here, and what is the true value? Okay, that is x bar. Okay, so the distance between these two points, for example AB, is x. Okay, so this is the distance, observed value between AB using tape or chain, and x bar is the true distance between A and B. Okay, now let us talk about this. No measurement is ever perfectly exact. Okay, I have told you we never know the true value. Okay, so whatever you measure, how precise you measure, how experienced the surveyor is, no measurements will be free from error. Okay, so every measurement contains some errors. Okay, so it will always be there, the error will be always there, so our job is to minimize this. Okay, so we never know the true value, I have already told you. Because of this we cannot know the exact error value. Okay, now here is one more point, because this error is, it is the difference between this observed and the true value, because we don't know this true value. Okay, so how can we know the exact error? So even this error, even this is very I will put it in a funny way. So there is an error even inside that error. Okay, so that this is very funny. Okay, there is some error even in this measured error. Okay, even the error is unknown. Okay, I mean it is not accurate. Okay, 100% accurate. Okay, so let me tell you one more point. So when we as we move on in the technology, okay, the least count of the measurement, the least count will increase. Okay, the accuracy will increase, but so we are coming we are coming closer to the true value. Okay, closer to true value. Okay, as we increase, as we use more and more expensive devices, more and more efficient devices, or we are going to come closer and closer to the true value, but we will never reach true value. Okay, so let us read this. So accuracy depends on the tools, markings, how reliable the instrument is, and human ability to read small divisions. Okay, so the tools, marking, and how reliable the instrument is, I have already told you about this. For example, this is a scale. Okay, these are the the divisions. Okay, so more the divisions, right, more the divisions, more divisions means more what, more accuracy, right, or rather more precision. All right, because if this scale, if the scale, this is a scale, right, if the scale have more number of small divisions, we will be able to even measure it more closely. Okay, for example, you have a distance, for example this is the distance that you want to measure. Okay, so when the number of divisions will increase here, so you will be able to measure to up to that mark. Okay, but again there is limitation to the human eyes. Okay, we cannot see everything. Okay, so because of this human limitation, there will be again some errors. Okay, so hopefully that's it for this class. Okay, if you have any doubts you can comment. Okay, so thank you for watching this lecture and see you in the next class. Thank you.